because you're kind of expert of what you're doing. So based on the results that you've gathered, so make a note, make a statement based on the graphs, so that it could be shared with the other person. You could establish your experiment or your research study to everyone, to yeah uh, uh, research institutions, so that it could be no a new leaf of information, so that it could be applied in the industry. It could be yeah an information, so that it could have a product. It could improve the production in the industry. It could prevent catastrophe. So many applications that we could actually use. So that will be in the part of social interfaces and implementations. So uh, how do we relate this in the outside world? So one of the example of it is uh, how the experts trying to say that in the next month there will be a rise of COVID positive. How can they do that? So uh, those are yeah. Actually, this is just not engineering problem, no solving process. It could be a generalized tool. So the expert try to detect the problem, which is the COVID, and try to gather more datas. They need initial datas. They need the theories. So oh, they declare the variables to be inputted in the mathematical model. So how the government uh, is working or implementing the rules in preventing the COVID, how the hospital, or how is the status of the hospitals, how the nurses cooperate, or uh, trying to fight the COVID, how people uh, responds to the pandemic, how people move from one place to another, so the movement of the people, and our transport systems, the possibilities of getting COVID positive. So it's being created in one mathematical model. So they need a data out, so that they could create that model, that they could solve it through numerical method or in their computers in the statistics, and they have graphical presentation after. Then by that they could share it in the society, that uh, based on the calculations that we do from the variables that we get in the situation right now, then there will be a rise or fall of COVID positive. So just like that, then the government will react to it and see to it that it will be prevented if there are rise of positives. So those things are kind of which important of how we respond with the situation right now. So the other example, of course, is how we predict typhoons. So do we how do we predict if there is a typhoon coming on our country, and how do we predict how it will gonna be strong if a if the storm itself is far away. Then how do we know if it will be strong, it will weakens on the part that it will land, no, and also where part of the provinces it will land, so that the provinces could actually prepare for what is coming. So it's kind of the same process, no? So actually for the typhoons, they're using softwares right now so that they could predict the movement of the typhoon, but the algorithm of those softwares, the algorithm of those computers are being derived in this engineering problem solving process, to which they actually using also numerical methods. Yeah, and yeah, of course they need the theories. Uh, they need, yeah, those are fluid mechanics. They need the data. They need the sensors. They need the satellites so that they have the initial data, so that they could calculate and they could predict the typhoons that is coming. Okay, so next one will be the softwares applications used for numerical method. So these yeah, logos, these brands, these softwares are kind of which needed programming skills, because MATLAB uses C, C plus, Excel VBA. So Excel and Excel VBA is different. Excel VBA uses a Visual Basic algorithm. Python is another program language, so that is Python language. So MATLAB is a software that uses C. So Python is a program language, so you could use Visual Studio to code Python, to code using Python language. You can also use Anaconda. So there are many softwares. So Google Apps Script uses HTML. So it kind of need programming skills so that you could create the algorithm, or you could create a program before, yeah, running it. Try it before yeah, calculate before it calculates. You need to input some coding so that it will work. The next one would be the softwares that you don't need to have skills in coding, but you need a skill in familiarizing the buttons, the how it operates. No, so for SolidWorks, these are very useful for, yeah, creating a mechanical designs. No, uh, it is very useful in fluid simulation. So the same with these other softwares, the NX, the ANSYS. So SolidWorks is kind of a student grade, but yeah, some of the industries uses it. So, but for research applications, it kind of a bit of a standard, because they they actually demand to use ANSYS, no, for your softwares, or your what type of program that you use for your calculations, for your simulations, no? So ANSYS is very more accurate compare of the other softwares. The NX is much of a technical type of software, same with SolidWorks, but yeah, industries most usually this SolidWorks use SolidWorks and NX. Compared to ANSYS, ANSYS is more likely in the research field, no, because it is more accurate compared of the other. Then yeah, the next slide would be the symbols used in flow charting. So we have terminal, we have flow lines, we have process, we have input or output, we have decision, we have junction, we have connectors, we have loops. So each of the names in flowcharts are does have a function, no? So I think you're familiar with this, or I think. So this is before you created a program, before you create uh, the codes in if you, before you input the codes, you made to sure that you understand the algorithm. And in industries, this flowcharting is a way to present an algorithm so that the program coder could actually, yeah, create the program that you wanted. They could create the code out with these flowcharts. So thus this is very important for communication, no? Because we have very vast of program language. No, we have the C, we have Java, we have HTML, we have we have Visual Basic, we have Python. So uh, right now the latest one are the vectors. So it's kind of evolving. So how do we understand na dili na lang ta magtanaw sa codes is just presenting a flowcharts. So how your programs run is based on what you understand in the flowcharts is being that is being used as reference. So ikaw would so if you understand the algorithm, you could actually create a flowcharts of yourself. Then we have error definition. So yeah, we have different types of errors here. So in numerical method, errors are very important, no? So that we could detect uh, or we could see how much error for this type of calculations, no? And more likely, the process and numerical method are using iterations. So the process will be repetitively done. So there will be repetitions of calculations, and more likely the error are the ones being used uh, as a as a decision making stage on how or where can you stop your calculations. So when you have a small error, maybe the type of error that type of value is already enough so that you could present the data. So the lesser the error, the accurate, of course, your data. So however, in the times of in these times, so you should probably, yeah, should probably know what errors it is acceptable, because yeah, less error, low error is kind of there will be more calculations of it, so it will take more time compared to the more errors that you get. So you should choose or you should decide how much error do you need so that you can save time. Okay. Yeah. It's not always that you need a very precise or accurate data, you know, for that application if the actual application does not need a 000 values. No? So later on the the when we introduce the methods, you will actually understand what am I saying with the errors. No? It's kind of how you will decide when to stop your calculations. So these are the errors, no? So the relative error, the true error, and tolerance. Actually, there are more errors that you can see in the 7th edition of Chapra, but these are the errors that we will be actually using, no? So more like the relative error, no? So just yeah, be remind of this formula or familiarize this formula. Then yeah, error definition. So true error, that will be the difference between the true value and approximation. The true percent relative error is the true value, the difference between true value and approximation divided by the true value multiplied by 100%. Then approximate percent relative error is the present approximation minus the previous approx all over the present approx times 100. Then the stopping criterion, yeah. So if the approximate percent relative error is less than uh, the desired percent relative error, yeah. You could use this yeah, stopping criterion, but most likely we are just using relative error as our stopping criterion. What what value of relative error is acceptable. Then we proceed with Taylor series. So the idea of Taylor series is just it is approximating a function. So for which any kind of function can be it can have an equivalent function in a certain region. Uh, that region can approximate using a could we could have an approximating value of that region out of the Taylor series. So the idea of approximating it's kind of which we are trying to apply in numerical method. That's why it is being part of the introduction. No? So the how how the Taylor series is being done is kind of how we do numerical method, because the more expansions that we get in Taylor series is the lesser the error or the more the accurate the data. So the longer the expansion, it will take time to write, it will take time to solve. More of which if we try to shorten the expansion, yeah, it will be more error, but still an acceptable one. Kind of which how we expand the pi, how we expand the Euler number, so those things, no? Like this. So the series expansion. So we have also a remainder. So it's up to you, know, of how long the expansion is, or how short or how short the equation, which is acceptable to your applications, to your preference. Yeah. So numerical differentiation, yeah, you will find this no later, no. So the numerical differentiation formula came from the Taylor series, no expansion. And that's it. So I hope that you learned something in this video, and I see you on the next one. Thank you and goodbye.